All right. Good night, good afternoon, good morning. We might have people from many places right now. So it's my pleasure to be here in droidCon Americas talking about coroutines. So today I'm going to have a talk about threading made easy with Kotlin Coroutines. So some of you may know about threading, about this concept, this programming concept that may scare some people. But today we will go from 0 to 100 to know how to master this using Kotlin coroutines. So first, let me present myself. I'm Eury Perez. As you saw on my profile, I work for X Team, which is a totally remote company based in Los Angeles. I work for one of the biggest clients, which is Beachbody, which is one of the biggest fitness companies in the United States, as a mobile team lead. I co-organize GDG Santo Domingo, Google Developer Group, also Women Tech Maker and Developer Student Clubs in my city, Santo Domingo. Also, I have more than 8 years of experience developing software, and specifically with Android, I have more than 6 years. I love to teach and also to give conferences, talks, and also I am a consultant for local companies in my country. I co-founded PrintSpace, and I'm a Christian leader. So let's start right away. So coroutines are lightweight threads, right? If you don't know this concept, in next slides I will be explaining, like for people that doesn't know anything about threading, some basic concepts. So are lightweight threads that we launch using a coroutine builder and live in a specific coroutine scope. We just mentioned a couple of key words here or key concepts here. We mentioned thread, we mentioned coroutine scope, and we mentioned coroutine builder. So let's go over these concepts to try to understand, to fully understand Kotlin coroutines. So first, this is an image that in a talk a while ago where when people from Google started talking about coroutines. And this is I always love to use this image because it's really clear on what coroutines are and how they work. So basically, we have a small example here of a suspend function. So suspend function is a function that can be run into a coroutine. And in the right, we can see an example or a visual representation of how this suspend function that will run in the background thread in a coroutine will work. So we see this white line in the middle that represents the UI thread where we draw our views, right? Where we draw our buttons, our text views, our edit text, right? So by the time we call fetch user, which is a suspend function, as we see, is represented by this icon in the left, which is that white arrow with that curve, with that green curve. So when we call that fetch user function, what it does is that it takes this out to a separate coroutine, which is similar to a thread, but it's like a lightweight version of a thread. So it takes it out to a separate coroutine and continues its work in the UI thread, drawing all the views, so it's not blocking our UI thread from showing, for example, our loading indicator or drawing our views, our text views, drawing our data. And then, meanwhile, our views are all being drawn. When it's finished doing the fetch user, it just comes back to the UI thread and show whatever we want to show. So you can see in the left, in that example, we have that call to that show function. So that's when fetch user finishes and returns, then the show is called. Meanwhile, our UI is not blocked. So let's start with thread. So let's see. I have I love to represent threads like with highways or roads, right? So a thread is a small set of instructions designed to be scheduled and executed by the CPU independently of the parent process, right? So you can think of like threads of as lanes. So later I have a better example. So and since threads are like small set of instructions, nowadays we have, and since a while ago, we have multi-threaded applications, right? So what multi-thread means? Multi-thread applications execute two or more threads concurrently, right? Like in parallel. Like we have this animation in the screen that we have we have multiple lanes, each one having multiple cars. So in the same way, threads have work in parallel, right? So it is also known as concurrency. And multi-threading is also known as concurrency. Each thread runs in parallel to each other. So this is pretty much what I was talking about. So each lane is a thread, right? So we have thread one, thread two, to thread six. So and in each thread we can have multiple tasks, right? For example, in this case, we have task one, which is this black car, and the other vehicle is task two, right? So we can have multiple tasks in a single thread. So and we can have multiple threads in a single process, right? So this is how multi-threaded application or concurrent application works. And this is how we are going to learn today how to use this, how to accomplish this using Kotlin Coroutines. So usually threads are heavyweight, right? But coroutines are different. We can launch many coroutines without affecting the performance. So in the past, people were afraid of using threads because if too many threads were open or with many tasks inside of it, and out of memory exceptions could occur or other performance issues, and that could affect the application itself. So with coroutines, we no longer have that issue. So and let's see. So in this example, we are launching a coroutine. We'll see every single part of this in detail later. So we are launching a new coroutine with the room blocking coroutine builder. This coroutine builder will block the UI thread. So in this case, we are repeating 100,000 times, and we are launching with the launch coroutine builder. We are launching 100,000 coroutines, and we are using the delay function to delay the print 1 second every time. So this is how lightweight coroutines are. So if you try to do this with threads, probably you will get an out of memory exception or any kind of errors or anything else, that can be bad for your application. But this is not the case for coroutines. So let's start with coroutine specific concepts, and let's talk about coroutine scope. So coroutines always execute under some coroutine context, right? So this is a set of multiple elements. The main ones are the job and the dispatcher, right? So remember this, all coroutines needs to be run under some coroutine context, right? So we also talked here about a job and a dispatcher. We will be seeing this later in detail. So to launch a new coroutine, you need a coroutine scope. And to build a coroutine scope, you do it passing a coroutine context as an argument, right? So in Android, we have some extensions to access a coroutine scope. So this can sound a little bit complex, but in Android, we don't need to build a coroutine scope ourselves. Sorry, we don't need to build a coroutine scope ourselves. So we have many extensions in many like Android components that can help us access to a coroutine scope that the library already built for us. For example, we have a view model, right? So for the view models, we have a view model scope, which is an extension that provides already a built coroutine scope that we can use, right? So you only need to install all your dependencies. You can just Google how to install all the dependencies for Android to work with Kotlin Coroutines, and you will be able to use this extension, right? So just use your extension, call any coroutine builder you want. In this case, you are using the launch coroutine builder, and inside of those curly braces, this is our new coroutine. So in the case of a lifecycle owner, for example, an activity or a fragment, we can use lifecycle scope. So this is the same. We just can use it to launch a new coroutine. And if we want to build our coroutine scope ourselves because we don't have access to a extension of those, for example, we want to create a new coroutine in a repository class that we have that is not a view model and isn't also a lifecycle owner. So we can build our coroutine scope ourselves. So what we do, we first create a job, right? There's multiple there are multiple ways of doing this. So here I'm showing you the most basic one. So previously I told you that the coroutine context is a mix of multiple components, right? I mentioned a job, I mentioned a dispatcher, right? So this here we can see this. So I'm creating a new job in a new variable, and in the next line, I'm creating a new coroutine scope. And as I told you, we need to pass a coroutine context as the argument of a coroutine scope. And as the coroutine context is a mix of multiple components, we can pass all those components with the plus operator. So in this case, I'm passing a job, and then I'm telling this coroutine scope to work on the IO dispatcher. I will explain this in a slide in some minutes. And then in our class, in our normal class, we can just use our coroutine scope like we do with the lifecycle scope or with the view model scope to launch our new coroutine with our coroutine builder. When creating a new coroutine scope, you can specify the dispatcher along with the name of the coroutine using the plus operator as we just saw. So this is another way of creating a new coroutine scope. So in this case, I'm not passing a job. So if you don't pass a job, you just will, like coroutine scope constructor will just assign a new job, just the same that we did, right? So in this case, we are building the coroutine context, just passing the IO dispatcher and the name of our coroutine. If we want our coroutine to have a specific name, we can do it this way. We just create a new instance of the coroutine name class and pass the name as a string as the argument of the constructor. Also, we can just pass the dispatcher, and this will also work to build a new coroutine context or new coroutine scope. So here I'm splitting it so you guys can see it in more detail. So we are first building a coroutine context. So this operation, dispatchers IO or plus coroutine name or dispatchers IO plus a job or just dispatchers IO will return a new coroutine context that we can pass to our new to our coroutine scope to get our new coroutine scope. So the library also offers an app-wide coroutine scope called global scope that can be used for more global purposes. This isn't so recommended for specific like use cases for view models for lifecycle scopes because like when you have a coroutine, you need to have access to it, right? You need to have control over it. If you need to cancel the work inside of the coroutine, if you're using the global scope, it isn't maybe that easy to do it, right? Also global scope is not attached to any specific context or any specific scope like we do when we build our own coroutine scope or when we use our vModel scope or when we use our lifecycle scope. But if you have something that is more global inside of your application and you want to pass that work to the background thread to a new coroutine, you can for sure use a global scope. So the next component is coroutine builder. We know how to build or get a coroutine scope, right? So now let's see how we can create a coroutine under that scope. So coroutine builders are helper functions that create a new coroutine. Let's see some of them. We already saw some. We saw the run blocking and saw the launch. So let's see others, and let's see what are the difference between them, and let's see also what are the best for every use case. So the launch coroutine builder. This function, you can think as this function as fire and forget, right? Because when you launch a new coroutine with the launch coroutine builder, you are not expecting any result. You just want to execute this task in the background, and you don't care about what the result is. You just wanted to complete that task and just end that coroutine. So in this case, we have this example in our main view model. We are using this view model scope, and we just can call launch from a view model scope. So inside of a coroutine, you don't need to call or to use a view model scope to call the launch because you already are in a view model scope. So inside of a coroutine, you just say launch if you want to create a child coroutine. And in this case, we also have another coroutine builder is the async coroutine builder. So if we are interested in the waiting for the result, we are interested in the response of that of that task that we are performing inside of that coroutine. For example, in this case, we are launching a new coroutine, right? And inside of it, we are launching another coroutine, a child coroutine with the async coroutine builder that is calling a get user, right? For this purpose, we need to call the await function on the async coroutine to let the system know that we want to wait for the result on that coroutine, and then we will just be able to use our user after the get user response. So there's another coroutine builder which is named with context, and it's pretty similar to the async coroutine builder. And I want you guys to know the difference between those. So when you need to execute multiple tasks in parallel and wait for all of them to process the response, use async. So if you have, for example, three calls that are independent from each other, and you don't need like one value to make the next call. You just need to make those three calls, and when the three calls finishes, you just do whatever you want to do. We'll see an example later when we go to the code. In those cases, we use async. But if we just want a value, right, and we want to wait for that value, we just use with context, like this one. So this is the same example we saw. So in this case, the best is to use with context. So as you see here, we don't need also to perform the await, to call the await function. We just call the with context. We pass dispatcher. In this case, I'm passing the default dispatcher. And inside of the curly braces, I'm calling the get user function. So, and this also is is faster than the async coroutine. So you can benchmark it yourself and see that this is a little bit faster than the async because it's performing less operations, backstage. So take this in consideration. If you need to wait, like if you need to perform 3, 4, any amount of calls that are totally independent each other, you use async. But if you just want to get a value from a single call, or you want to get a value to use it in the next call, you use with context. And then we have run blocking that is not very useful in production environments because we don't usually want to block our UI thread. So this is used more for examples, right? When we are working with Kotlin and we use this main function that we don't want also. By the way, if we like create a new coroutine, right? And there is not run blocking. What it will do is that it will take that task that we put to them, print anything or calculate anything to the background, and the program will just finish right away. So to prevent the program not finishing right away, we use a run blocking. So this is another coroutine builder. And as you see, for this one, we don't need to create a new coroutine scope or access or get a new coroutine scope from anywhere. We just use run blocking and that's it. So we have mentioned the dispatchers many times now. So let's see what is this about. So when creating a coroutine scope or launching a new coroutine, we can specify the dispatcher, which is part of the coroutine context as you saw previously. Remember that when we were creating our new coroutine scope, we could pass a job plus a dispatcher plus a coroutine name if we want to name our coroutines of a specific way. And the dispatcher will determine the thread or the threads that the coroutine will use for its execution. So coroutines are that flexible that we can also control in which threads or thread the coroutine will execute. So these are the different type of dispatcher. So first we have the default, and this is used if we don't pass any dispatcher when launching a coroutine or when creating a new coroutine scope. We use the default dispatcher that uses a common pool of shared background threads. This is recommended for coroutine performing tasks that will be very CPU consuming. Secondly, we have the I/O dispatcher, which is the example we just saw in the previous example. So this uses a shared pool of on-demand created threads. So we don't, it's different from the default that are shared background threads. We have a pool of threads there. No, but the I/O are created on demand. So every time you launch coroutine, if there is no I/O thread available, the system will create a new I/O thread. So the coroutine can execute there. So this is recommended for offloading of I/O intensive blocking operations like files I/O and samples. Also, we have the unconfined dispatcher. This will start the coroutine in the current call frame until the first suspension. So if we call the coroutine with the in main thread, it will stay there until the next suspension. So when the unconfined dispatcher detects that there is a heavy operation that wants to suspend the current coroutine, it will then change the thread and gets back to the caller thread when the suspensions end. So you can recall the example we were seeing in the beginning of that fetch user or fetch data function that will like go outside of the main thread and go to a separate thread and complete and then comes back. So the unconfined does that, but it changes thread as soon as it detects the first suspension. So the name is given because the coroutine is not confined to any specific thread or pool of threads. It's not recommended for use in production, right? And we can create our own thread by using the new single thread context um, builders or the new fixed thread pool context builder functions. So we are also mentioned suspend functions, right? So let's see what are these. Suspend functions are mainly functions that can be paused and resumed through the time. So they can execute long-running operations and must be called from within a coroutine. So if there is any work that you can think of, like a work that can be moved to a background thread or to a work that can be asynchronous, right? That can suspend the current thread and that can resume the current thread later with the value or with the response of the task that we performed. In that case, we can use a suspend function. So the last part is also important. We can only call the suspend function from within a coroutine. This is the syntax of a suspend function. It's a normal function. We just add the suspend keyword in the beginning before the fun keyword. So also inside of the suspend function, we can use any of the keywords or the function that we can use inside of the coroutine. For example, we can use the delay function. That is a function that is only available inside of the coroutine scope, because when we call a suspend function, I just said that we can only call a suspend function from within a coroutine. So what will happen is that the suspend function will inherit or will take the scope from the parent coroutine, right? So this is why it has access to a coroutine scope, because it takes the coroutine scope from the coroutine that called this suspend function. Suspend functions are sequential by default. Let's see when we should go sequential or concurrent. And this is very interesting. And this is one of the best parts of coroutines. See how we can control whether we want to go sequential, waiting for the next result, or whether we want to go concurrent and just make many calls in parallel. And this is something we need to know, because this is something that can make a significant impact in our performance of the application. So, for example, we have this visual representation. We have these two blue squares that are two suspend functions that are get random value 1 and get random, the next one have a typo. It should be get random value 1 and get random value 2. So each one of them lasts for 100 milliseconds, let's say 1 second. So you see in the top part that both last approximately 2 seconds, right? And we first execute the get random value 1, then the get random value 2, and then we get our result. So these are the two suspend functions. It's just a random, I have an extension that just generates a random integer, and to simulate that we are doing a heavy job, I just added a delay of 1 second, right? So here we have also another coroutine builder that I didn't mention before, is measured time millis, that will measure or will return the time in milliseconds that your task lasted, right? So in this case, we are launching a new coroutine with the measure time millis coroutine builder, and we are executing our two suspend functions, right? We are calling get random value 1 and get random value 2. And in this case, as I told you before, suspend functions are sequential by default. So what it will do is that it will return the num1 or the whatever number get random value 1 returns. And then when it finishes, it will call get random value 2, and then it will call the log.d that will print out the result of these two numbers, right? So we can see down the logs that were generated by this. First, the result was 91 to random values that were generated, and we just summed those numbers. And then you can see that it completed in 2048 milliseconds. So 2 seconds, a little bit more. So let's see how we can improve the performance of these operations, since we don't need anything from num1 to like in get random value 2. So these two calls are independent. So let's see how we can do it the concurrent way. So in this case, we are doing the same measure time millis coroutine builder. We are using that coroutine builder to measure our the time that it lasts, that it takes to do everything. So, and before we saw how to use the async coroutine builder, and we said that this is useful when we have multiple tasks or multiple operations that we want to get the values from that operation, and by the end of it, we want to get all the values. So this is the example I promised you. We have get random value 1 and get random value 2, right? And we wrap those inside a new coroutine using the async coroutine builder. So what this will do is that it will take Like before, we were performing the two operations in the same coroutine, right? We have the get random value one and the get random value two inside of the same coroutine. You can think of it as a box, for example. You were performing that on the same box. And now what I'm doing is that I'm putting every operation in a separate box, in a different box, using the new async, using the async coroutine builder. So what this will cause is that it will, so you see in the next line, the result, I'm doing num1 dot await plus num2 dot await. What this will do is that it will wait for the operation that takes longer, and then it will print, right? So the total time of this total operation will be the function that takes longer. So in this case, you can see below that later this lasted for 2 seconds, a little bit more, and now it's 1031 milliseconds. So it's a little bit more than 1 second. So this way you can improve your code, improve your calls to the API, for example, or your files reading or whatever you are doing that is heavy. And if you don't need anything from the previous call on the next one, you can run this in parallel and cut the total time maybe in half, or can make a significant impact. And this is a visual representation of what we just said and what we just did. So we have two different suspend functions, and we do it in parallel, and it's lasting for around 1 second. So let's see about canceling a coroutine. So when writing a concurrent code, it's imperative to have control of the tasks being executed, because we don't know when the user navigates away, or when the user wants to just cancel the operations. The operation is just being executed in the background. So we need to have control over that. So coroutines offer that level of control to us. In this case, I'm showing you how to do it. It's very simple. So when we call a coroutine, when we create, a new coroutine, for example, with the launch coroutine builder, this returns a job object, right? The job object then has, by the job object, we have access to the cancel function. So we just need to, if in the future we would like to cancel the coroutine we just created, we just need to save the new coroutine builder call inside of a variable, and can just call cancel on that job later. Other coroutine builders like async return a type deferred of T that inherits from job. So deferred is a type that is a child of the job class. So the cancel function will be there also if you use the async coroutine builders or any other coroutine builder that will return a deferred. So cancellation can be performed the same way. An important consideration is that coroutine's cancellation is cooperative. What this means? This means that when you cancel a coroutine, the isActive property of that coroutine is set to false, but the job will continue running. Right? If you have, for example, a for loop that is doing a heavy operation every time, it's a good idea to check the isActive property inside of that for loop, so you can just cancel your operation as soon as this property um, changes. Once the job, like if we have a job, like it's not a for loop, so we cannot check the property to cancel it inside of the coroutine. Once the job has finished, it will throw a cancelable exception, and the job will be considered completed. So it will throw that exception, and the coroutine will be finished. This also applies to suspend functions. For example, if we have two suspend functions calls inside a coroutine, and we cancel the first one, we cancel while the first one is doing its job. The first will finish and will throw the exception, and the second one won't be executed, because the parent coroutine will just throw that exception of cancelable exception, and that will be it for that coroutine. So talk is cheap. Show me the code. Now let's build something to see the coroutines in practice. So let's see how this works. Let's build a social network like app using coroutines. So we have I will show you because I will be using a fake API page that I just found yesterday, and to consume some fake endpoints. And let's see how we can consume all these endpoints concurrently, and how we can take advantage of coroutines to make these really readable and really good for how good for performance can coroutine be. So you can see this animation in the right side of the screen. So we'll have multiple modules. We'll have a set of albums. We'll have a set of to-do items. We will have a list of posts. We will have inside of the posts. We'll have a list of comments. So let's see how we can um, let's see how we can go. Oh, sorry. Let's see how we can just use the coroutines to. Let me just reopen this. Okay. So this is the a little project that I built, which is the same I just showed you. Obviously, it's not working as you saw it in the animation, because I want you to see while I write the code, right? So I can show you step by step, and in the end, we can share, and you can ask me questions and all that. So let's go over um, let's go over our project, right? So we have three packages. We have one main activity. We will be using navigation components. So we are going to have a main fragment, which is the fragment you just saw in the animation, which is this one. Um, we will have also a post fragment, which will be the post detail fragment. When we click on a post in the main fragment, we will see this. And we will also have a post create fragment that obviously by the name we will be creating posts in that specific screen. So we will have these three packages, right? So we'll have data, we'll have UI, and util. So let's go over all the classes so you guys have context of what we are going to be building. So inside of the data package, we have the models we are going to be using. So I told you that we'll be using an album. So and first, maybe it's a good idea to show you the API I used. And this is it. This is the the fake API that I just found, and it just offers many endpoints that we can use. For example, we have a post, comments, albums, photos, to dos, whatever. So it will just return a JSON and a list, or a single one depending on how you make the call. So this is what what we are going to be um, processing right now. So um, the first model is the album. So the album just have an ID, user ID, a title for the album, and a thumbnail. So we have a comment. So each post have multiple comments. So we will be displaying those. We will display the name, the email, and the body. So we have a photo, we have a post, right, which is just a title and a body, and we have a to-do, which is just a title and if it's complete or not. So we have also some repositories. So we have a user repository to get those albums, right, or those to-dos from the API. We have also a post repository to get the posts, to get a single post, to create a post, or to get the comments from a specific post ID, right? I have a dummy object here called session manager just to simulate that I have a session object just to give me the user ID I'm going to be using. And we have also the network package that, sorry. So, and we have our network package that will have this object. So if you are familiar to retrofit, you will be able to understand all this. Um, Basically, we have here configuration. We have the HTTP client that we are like configuring with a new with two interceptors that we are passing the base URL, which is the base URL for the fake API page that I just showed you. Um, just using JSON for the conversion, and that's it. So, and I'm also adding this property so I can easily access the service from outside of this. And we have all the endpoints that we will be hitting. So we will be calling these get posts. This is the route for this. This just returns a list of posts. We will be hitting a get post or a single one. We will be creating a post. We will be getting some the comments for a specific post ID. We will be getting some albums and to-dos. Um, So let's go to the UI package. So here we have, for example, for the main fragment, which is the one you just saw in this animation, it's really simple. There's a specific architecture that I explained in a talk in the droidCon Europe. Also, I have a blog post uh, about that. You can go to my blog and see it because I don't want to take much time on this in these talks since we are covering coroutines. But I have in the main fragment I just have a recycler view, and each one of these elements are a separate view holder or a separate component, right? So in this case, in the main fragment, we just have we are just initializing that recycler view with our adapter, and we have our adapter here that we created. As I told you, every thing of those are component, right? So here I am creating a view holder for each one of those components. For example, we have the create post component, which is just the top part that you saw. Um, we have the title component, which is this, the title for every time we want to do a title. We have the album, which is the horizontal recycler view showing all the pictures. We have to do type of component, which is the also a horizontal list, but with a different item, which is the to do item, which is just a card view with you see with just text view inside. And also we have a post, which is a vertical recycler view, um, just to show these items. So we just since we are, I will show you um, I will show you the architecture real quick, so you understand this. So I created a seal class, which is called main screen list item, which receives an item type, which is just an enum that will help us identify the item type in the adapter, just to for this property that needs to return an integer. So we just use it for this since we are using seal class and enums are no longer needed. But anyway, we are using this enum in order to identifying the item type for the create view holder. And we have our create post list item, which is an object because it doesn't have any data inside of it. We have a title list item, which contains a title, the title and other properties. We have the album list item, which contains the list of the albums that we will be showing as a horizontal list. We have the to-dos, the same thing. And we have posts, also a list that we will be showing in a vertical recycler view. And then here, since we are doing this on a generic way, for example, we have a base view holder that will be initialized. with the type T, which is a children of any, like, would be any type that belongs to this type, right? So can be any of these classes, can be passed as a generic type of the base view holder, and all of the view holders that inherit this should implement um, this bind class, which will accept an item of type T as the argument. So this is why I can just call here holder that bind, because I'm doing it just with the base view holder and with the generic type, and all of the view holders that I'm creating complies with this, and I just need to pass the item from this. That should be one of these items, right? So let's see. No, first let's see our view holders. So we just saw the main adapter. So we have the album list view holder is really simple. We just have a recycler view for the horizontal list. We have the album adapter, which is a simple recycler view adapter, and we just initialize the recycler view and just bind whenever we call the bind function. The same, for example, for the to-dos. You see it's pretty similar. It's almost the same. And also for the title, we just set the text from coming from the item, and I have a as ECO visible property to hide or show the CO link in that title. Also, we have the post, which is also the same, really simple, just a recycler view and adapter, and the create post with just the text they click. So anytime someone clicks on that item view, we pass down an action. So, and you might have seen this lambda expression here. So this is what we do, what I'm doing to pass down the action. So I'm not implementing or passing any interface. I'm just doing it with lambda expressions. So what I do is that I created the lambda expression that accepts a main screen item actions, a return unit. So main screen item action is any action that can be performed by any of these elements or these components or modules in my main fragment. For example, one action can be create post clicked action. Another one is if someone clicked on CO, or someone clicked on a photo in an album, or someone clicked on a post, right? So the good thing about this is that we take advantage of the CL class, and at the same time we take advantage of the SmartCast. We will see that later, because we can pass down the information we need for every event, right? So for this event, I need to know the post that was clicked. For this event, I need to know the album that was clicked, and so on. So in the main fragment, when we create our adapter, right, we pass the same lambda expression, and this same lambda expression, we pass it down to the beholder, which is the same we just saw. So when we create our adapter, we have just to create a new function here. This is warning because I'm not implementing all of them. So now it goes away. So when we create a adapter and I pass the argument, the lambda function, so I need to create a function that complies with this signature, and a function that accepts a main screen item action as the argument and returns unit. So, and that's really easy. So that's what I did. I create the onAction function, and I can just pass the reference to that action function. And when that action happens in my view holder, it would just take the reference that we are passing through the adapter and call directly this function out here. And when we get that action, we can use the when expression to take advantage of the SmartCast. So if it's a post-click action, I have no data inside of it. But if it's a create post-click action, no, this is a post-click action, I can have the post ID, right? Because inside of here, I have this argument, which is of type post, right? So just by um, asking of the type, just by asking the type of the post clicked action or the main screen item action, it will cast the action object to one of to the one I'm asking to. So right now, if you see action here is of type post clicked action. So that's why I can access the post. So, and that's how we created our adapter, our modules, our view holders. So let's see how what we have in our view model. And this is what we are going to rewrite. So this is the interesting part. So in this case, we have many. So let me first go to yeah, we saw the repositories, right? So in our repository that we saw, we have if you are familiar to retrofit, you know the enqueue function that we use to get a callback whenever the call failed or successfully responded. So in this case, we are calling the get albums and queuing that call and passing down a callback that we'll be using to know whether the call responded or failed, right? So in this case, we are doing the old callback way that we are going to rewrite to see how we can improve all these using coroutines. So you see how difficult to understand is all this, like many repeated code just to add a callback. This cannot be used like on a sequential way like we do with suspend functions, for example. It's a mess if we want to nest, for example, calls. So what we do, for example, if we want to load the comments after we load the post, for example, we need to call this inside of this, and it can get really messy, right? So I didn't even finish this code, so it doesn't even run, or if it runs, it doesn't even work, right? It won't show nothing. So what we do here, we have multiple live data to notify our UI of every time our API calls respond, right? So let's rewrite all of this using um, Kotlin Coroutines. So since retrofit version 2.6, I think it is, retrofit supports Kotlin Coroutines. So the first thing we are going to do is we are going to come here and we are going to make all these functions suspend functions, right? So we remember that the definition we read about suspend functions are functions that can be paused and resumed through the time. So we are making these functions that can work inside of coroutines and that can be paused and resumed through the time. And also, we are going to remove the generic wrapper for the return type, and we are just letting it like if it was a normal function, just with the return type, no call or response or anything. We are removing this, and it will fail in our repositories, right? So we need to now go to our repositories, and we no longer need this because we are going to return our values right away. So this is failing. Why? Because this is now a suspend function. Suspend function. As you see, suspend function should only be called from a coroutine or another suspend function. So we need to make this also a suspend function. So this doesn't fail. As you see here, you see this little icon. This represents that this is a suspend function call. We no longer need to do this and this. So and now let's move to the post repository and do the same. Make all this suspend function. and remove the arguments. See, so here we need the post to create the post, but we don't need the callback. And here we need the post ID in order to grab the comments for that post, but we don't need the callback. So now let's just place all this. And oh, here I removed the post ID. Yeah. So now we have we have our retrofit service endpoints on a coroutine way, so spend functions, and we also have our repositories in that same way. So what we do here, so now instead of having this messy functions, what we are going to do is that we are going to delete all this, and we are going to use async to make all these calls in parallel, since we don't need to make these calls sequentially, right? So the first is albums, right? So I will launch a new coroutine by using the async operator, and we'll use the user repository to get the albums, and that's it. So the callback and all the code we had is as simple as this. Now we are getting a deferred here that we will await later. So let's continue. We are going to have to grab the to-dos, same. I'm creating a new coroutine to grab the to-dos. And also we will get a new coroutine to grab the posts. So we are getting all the posts, right? So we are going to create a function that will process all this, like process. No, let's create it on. Let's let Angular Studio help us. Let's call it process data, and we'll just pass albums data weight, to-dos data weight, and posts data weight. So this is the same we just saw in the previous example, if you remember. So what we do here is that we wait for the last operation to complete, and then this line will be executed. So this is great for performance, is very readable, is really simple. So let's create a function and change these names, call these albums, to-dos, and posts. So as you see, we no longer need these live data, and what we are going to do is that we are going to build a new list and passing it to our model list. So in our UI, we are just listening to this live data, and we are updating our adapter items with that list that we are passing. So here we need to create. We are going to create a new list, and this is a list of main screen list items. So the first one we had in our example is a create new post. So we will be adding a new create new post list item. Then we had a title for the albums, right? So we create a title, this item. And for the sake of simplicity, I won't add it to the resources. I will just hard code it and put albums. So this is expecting also a content item tab. I don't know if we're going to use this, so I'm going to remove it, and then when it failed, I just or just let me do this. Yeah. So then we are going to have a horizontal list for the albums, right? So we need a album list item that needs a list of albums. Then we will need another title for the to-dos. Name it like this. And we are going to need a to-dos list item that accepts a to-dos, a list of to-do. And posts list item, which will render all the posts as a vertical list in the bottom of all the components. You see? So we have this create new post, this title, this horizontal list, this other title, this horizontal list, and then the posts just in the bottom. And here we pass the post. And let me build, see if there's anything wrong, so I can fix it before we run it, and we should be okay just now. See? So as you saw, we have this module list property that I just added a custom setter that every time I set this this property in this view model, I will update, I will post value to the live data, right? So everything went okay. Let's see if everything is okay or if we need to fix something else. Now we will know. Okay, so everything worked good. Nothing better for a live code session of it working the first time. So we just loaded everything. You saw that it loaded really fast. I will just close this and reopen it so you can see it again. It loads really, really fast. As you see, it takes less than a second or a second to load everything. So it makes a call to load the albums, makes a call to load the to-dos, makes a call to load the posts, right? And now let's implement the post creation and the post to create, to you know, um, see the detail for a single post. And for this, we can go to the post view model, right? We have a post create fragment that I told you about before, and we have a post fragment where we show the details of that post. So it's the same. Here we just have a live data that we observe and we show the data once we get this. And that's it. Let's see in the view model what we have to do. So here we have fetch post data and create post. So let's start with the fetch post data. Here we are going to launch a new coroutine in order to create a new coroutine to then to grab the data. So now I will launch an async, or I think here I can do, oh yeah, I need to do the comments also, comment calls. So the async is good, so 2 calls independent. And I will make the call to get the get post given this post ID that I have here that I am getting from the arguments that I'm passing. So for example, here in the main fragment, whenever a post is clicked, I get the post ID here, right? The post, and I'm using navigation component, so I'm passing the post ID through the arguments. So let's grab the post. So asynchronously, I will make this call, and also I'm interested in getting the comments. So let's also make that call. So I'm calling the get comments that also needs the post ID. I created this data class here to pass to the live data because this will contain a property post and a property comments. So we don't need to submit to 2 different live data. So in this case, I will post data, live data, that post value, and I will create a new instance of the post screen data, and I will pass post and comments, right? So in this case, it is failing because these are deferred, right? I need to add the await call that will actually return the value after the process finishes. And this will take as long as the longer calls execute. So we should be good. Let's see. We just post to that live data, and in the post fragment, we just listen to this. We just add, we have a comment adapter that we just update with the comments and show the post data, which is just showing the title and the content. So let's see. We are good. It loads pretty fast. It loads all the data, and it's great. Look at all the comments here. Look at all the comments. Great. So let's finish up um, by adding the post create call, right? So here we have a create post, and we can do this. We don't need the async anymore because we are not waiting for the result to do something else. So here we are using our view model scope to launch a new coroutine, and we just can call the post repository directly that create post and just pass a post, right? And that should be good. So we also let's see, yeah, yeah. In this case, we are posting to this live data. So yeah, in fact, we need to grab this, and I need to name this differently because the argument is named the same. And when this finishes, I just post that value out. And also, we need the await. But in this case, I think it's okay to use the with context. Let's see. With context, so we want the dispatcher IO, and we just have our value, and that's it. So as I told you, in these cases where we have multiple calls going independently, we can use the async to call await on all of those. But if we have a single call that we want, we can just use with context, and it will be just the same, and it will be way faster. Um, let's run it. Let's see how it goes. I didn't add any particular behavior for the create post. I just showing a toast, but in the logs, you see post created. But in the logs, we will be confirming that our posts were created. So you see that I created this. Hey, this is my new post. This has some hard coded title, and this is my um, user ID, and it returns 201. So it all went great. So, and that's how we just built a multi API call landing page or main fragment for our application using Kotlin Coroutines as simple as this. We just launch a new coroutine, launch coroutines for each one of the calls, and then I'll wait for the result of those calls, and it will return after the longer one returns, and we'll just process the data, create our module list, and post it to our live data. So we have I think 20 minutes left, and I will stop sharing so I can read your questions. To read your questions, guys. I was checking you guys were making some questions, so let's see. So, okay, so how do we chain calls together? Like if the second call depends on data received. Oh, that went away. Oh, I need to read the first one. Okay, my app is Behemoth, so I still got a lot of Java code. What does Java interoperability look like? Like you can run coroutines in any Kotlin code, right? You can, like, you know that Kotlin and Java are very interoperable. So if you have your Kotlin code, your Kotlin view model, for example, you can just use Kotlin coroutines. You are not able to use any of these in Java, but you can like start migrating at least your API calls to Kotlin and use Kotlin coroutines. So debugging suspend sometimes become really painful because the debug pointer doesn't hit it always. How to make debugging suspend functions better? Well, in the beginning of the talk, I was showing how we can add I show in two ways. Like we showed, if we are creating our coroutine scope ourselves, I showed how we can name our coroutine. We can put it in. Also, when we are setting the dispatcher, um, we can name the dispatcher for debugging. So you can in the documentation you can find it. I don't remember right now the specific keyword, but it's just with the coroutine name. Then you can log things, and it will print out with your suspend function name, and you will be able to debug. Can you share some best practices for unit testing with coroutines? Well, in this presentation, I didn't include that, but I can promise you to maybe write a blog post for later, and you can visit my blog. I will later present a slide with all my social networks like LinkedIn, GitHub, and my blog. Did I miss the error handling when you replace the old methods with coroutines? No, I didn't add for the sake of simplicity and for not taking too much time. I um, I didn't include error handling or loading. So the thing is that this like just the same as you get your value, you can get a wrapper as we normally do, like a data result wrapper or a network result wrapper with the result or the error, and we can just as simple as it looks, we can just validate it is an error or not, or and dispatch to live data or other, depending on that. Are you familiar with Mosby's MVP? If so, any suggestions on which scope to use in the presenters? I'm not familiar with Mosby's MVP, but I will take a look, and maybe uh, in the future I can respond. Mm, no one knows. So could we see the coroutine specific code? Yes, all these Kotlin is you can see all the Kotlin code. So if you command click on launch, for example, or an async, you can see the implementation of all that. Will the code be available on GitHub for further studies? The code is available on GitHub right now, so you can go to my GitHub. Eury is EURI 16, and you can see my latest repo, which is for this presentation. How do we chain calls together? Like the second call depends on data received from the first call. So this is the default behavior. So when you have two suspend functions and you call these two suspend functions, it will chain the two calls together. And for example, if you want to, if you are using the async that I just showed, and you need to pass the value coming in the first one, in the second one, you can just add the await inside of the arguments of the second one, and it will wait for that result, make that call. You see, so it will be sequential. On this example, on main model, how would you approach to make each call independent from each other and update the UI as soon as it gets there? This is very interesting because this is something we just have done in my job. We have just needed to implement something like this. So it's as simple as making. You can separate that on different suspend functions. You can have your suspend functions with your async call, and you can have your live data post value inside of each suspend function. So since each async coroutine builder will create a new coroutine, it will be already independent, right? It will be in a separate box. So since you're in that separate box, you make the call and you post the value, and you can have four different calls at the same time that you create with the async coroutine builder, and when it finishes, and then it will post the value. So and that's how you can do it. Well, the recording will be available. I don't know. Maybe the droidCon team will let you know later. When do we use cancellation token? So in this case, when you cancel, well, I don't know if I understood that question. If it was what I said in the presentation, you can cancel it just by grabbing the job that is returned by the launch or the async or whatever coroutine builder, and just cancel, but call the cancel function. Didn't you just say a spend function must be in a coroutine, but your first example is in ordinary code, not even include. No, that's not possible. You maybe you just you got confused because it's an error. So you will get an error if you try to call a suspend function inside of a of normal code. It needs to be inside of a coroutine. You can go to my GitHub and see all the code so you can see. Oh, also you can check the branch which is called 3-coroutine. So I have 3 branches in that repo. You need to switch to the branch coroutines. If we were returning a list of items from the API, can we iterate that list and call another API for each item in the list, similar to RxJava flat map iterable? Yeah, for sure. So we have in Kotlin, we like the good things of Kotlin and Kotlin coroutines in general is that completely get rid of RxJava. So in Kotlin, for example, we have the flat map also as RxJava, and we can just call or create a new launch a new coroutine for each one of the items. I just did that like a week ago in my job. Is async runs on dispatcher IO by default? No, there is a dispatcher that default that is used when no dispatcher is used. What about async that await all? Yeah, we have many possibilities with coroutine builders and all that, so you can go ahead and try all of them. How can I make coroutine work with Java API which returns async response through a callback? That's a very good question, and I regret a lot that I didn't include that. But please investigate about suspend cancelable coroutine. Suspend cancelable coroutine. That's a helper that the Kotlin coroutines have to um, translate or to convert from callback to coroutine. In that case, we just we have a continuation that we call, for example, when the callback responded or error, we call that continuation to complete the coroutine work. Can you add the presentation deck? Yeah, I can add the presentation to hear and talk. And yeah, that's pretty much it for me. So I would like to share again now, so I can share um, my social networks, so people can find me. Let's see. Oh, another question. Can you talk? Can you talk a little bit about supervisor job, booster job? Well, I didn't have much time, but yeah, you can find that info in the blog post. I wrote about coroutines because I don't want to take other speakers' time. So those coroutines share resources between each other, like memory. No, coroutines are independent. Um, let's see. So yeah, these are my social networks. You can find me in Twitter _UryPress, in LinkedIn UryPress, my blog UryPress.dev, and in my GitHub Eury with I16. And there in my GitHub also you can find the repository that I used, the code that I used for this talk. And that's pretty much it for me. I hope I have, well, someone asked for my Medium, so this is my blog, eurypress.dev. So it was a pleasure to talk to you guys. I hope we see you. I can see you later. You can find me in my social network. You can ping me if you need something. Um, yeah, that's it for me. Thank you very much, everybody.